Hello and welcome everyone. Greetings for the day. So I would like to firstly thank all the organizers, that is Dassault System SOLIDWORKS Corporation and the LN4 Foundation, for organizing such an innovative project competition and enabling us to participate for a good cause. So I will be presenting before you now my project submission for this Arm for All design contest. So we already know the goal of this design contest was to provide LN4 Foundation with the design that is an improve upon of an above and below elbow device for the existing LN4 prosthetic hands. So with that said, here is my design which I modeled using Dassault System SOLIDWORKS, and there has been an effective usage of the 3D experience platform in it. So once again, thank you for this opportunity. So the complete design process started by just initial design concepts, sort of just sketching. So you could see on my camera below, these are certain sketches which I initially made for the particular prosthetic arm to manufacture. So this arm was manufactured with an intent of designing and manufacturing it with the help of additive manufacturing or 3D printing in general, so that the complete structure would be assembled and with the intent of design for additive manufacturing, so that it will be lightweight, easy to put, and there has been a respect of all the specification. So here is a joint in my design which is going to be mounted on the existing LN4 arm, which has the following specifications being mentioned, and then it will be mounted to a forearm like structure which has a male and female component which will be intact together with the help of few screws. Lastly, the assembly will be intact together with the help of hinge-like structures which the already LN4 Foundation's arm already has, and it will be mounted to a cuff-like structure, so it will be overall structure to a end use of that particular limb of a patient. So here is a short animation of my design. As you can see, the arm is already been mounted to a joint, and this joint is going to have that particular LN4 structure arm. So this will be the location wherein the arm will be mounted, and you could see the male and female components that of the forearms are being mounted with the help of few screws. Now this will be again mounted with the help of a nut and bolt arrangement, and this hinge joint will help us to connect the cuff-like structure to the end use of the patient. So here is the overall assembly. If you could see this assembly, as I mentioned, here is going to be the structure wherein the entire arm is going to be mounted, and here is the prosthetic arm, forearm, and here is the presence of the joint, as I mentioned. Here are the few renderings of the design which are done using SOLIDWORKS Visualize connected. So the 3D printing specifications will go as above. So the entire process manufacturing was done using FDM based 3D printers, and the material used was PLA. The layer height used for 3D printing was about 0.2 mm, which is generally the standard layer height, and the infill percentage were 10%. The total weight of the components, including the support, was found to be 650 grams, and the extrusion speed while 3D printing was 110 millimeters per second. The total print time which required in order to manufacture this was about 26 hours, but we can still reduce the printing time based upon the quality of the requirements which we have and based upon the design modifications. The nozzle size used was 0.4 mm. Here are the few images of my design. So the basic advantages of the design would be it will be easy to clean and repair if in case of any damages, if the damages are prone to occur. It is basically an inexpensive design since it has enough of space, so it is breathable and no odor will be present in and out. It will be waterproof and no round edges or curves are present. So it's aesthetically owning to its personalization and customizable. The lightweight and ergonomic design also helps it to be a key factor for the design to be just been used for a larger scale. Now this particular joint, as I mentioned, has been replaced by a small joint which will be directly being placed with the help of a cuff. So the forearm will be interchangeably used with the help of the longer version and the shorter version. So for above and below elbow devices, we can interchangeably shift this particular assembly so that we could manufacture less number of parts, and the same parts can be used for this particular assembly again. So thank you for this section. I would like to explain about the detailed description of the assembly in the later part of the section. Thank you.